So welcome to Web Security. If you're here for Math 104, that's over there. This is Web Security, as you can tell by the amazing graphics that have been up here. I'm Faraz. I'm going to be the instructor for the class. And Esther, are you here? I don't see Esther. So the TA will be here shortly, hopefully, and you can all meet her. But yeah, we'll go ahead and get started. So just first, some administrative stuff. So the website is right there, and we're gonna have 5 to 6 assignments in the course, and they're gonna be mostly programming assignments. Though there may be. Oh, there's Esther. Hi, Esther. Say hi to everybody. Hi, everybody. So that's our TA. We're both really excited about the material in this class. So we're hoping to share our enthusiasm with it with you guys. And it's going to be great. So to the administrative stuff. So 5 to 6 assignments. Most of them are going to be programming assignments. And there's going to be maybe one written assignment with like questions. I think that's what we're going to aim for. You can go ahead and take a look at assignment 0. It's going to come out tonight and see what it's going to kind of be like. We're going to have 7 to 8 guest lectures, which is about a third of the lectures in this class. Part of the reason why we're doing that is this is a new class, so it's easing the burden on me in creating all the material in one way. But furthermore, it's about getting industry people to come in and share like cutting edge web security stuff with you all. So we have a bunch of exciting speakers lined up. There's a few that are already on the site that you can take a look at. One of the speakers is with the Brave web browser, which is a privacy-oriented web browser, and he's going to be coming in and talking about anti-fingerprinting, which is basically the idea is how can you make a browser that is impervious to being like we'll get into fingerprinting, but basically the idea is you want to make it so that like when you actually clear your cookies in your browser, that you're actually sort of completely you have a fresh profile, and an advertiser or somebody can't follow you around even though you've done that. So we're going to talk about that. Another one of the guest speakers is a pair coming from the Google Chrome team, and they're going to talk about some of the security work that the Chrome team is doing. And we have a bunch of other really cool people. Someone from GitHub Security, and a couple more that are still being finalized right now. But it's going to be really cool. So we're going to use Piazza for questions. And since this is a new class, it would be really awesome if any of you have feedback to share that with me. And there's a form on the website where you can submit anonymous feedback. So about assignment 0. So the idea behind this is it's just a way to get a feel for whether you have the like requisite sort of HTML and JavaScript knowledge that you're going to need for the class. So there's not a prereq on any kind of security for this class. So this can be your first security class. That's totally fine. If it's not your first security class, don't worry. There's still going to be a lot for you to learn completely new stuff that's different from something you might have taken like CS 155, the intro to security class. Because in that class, there's only time for about 3 weeks of web security material, and this is going to be, the whole class is just web security. So with assignment 0, there's going to be these 3 workshops that you're going to have to do. They're like little interactive terminal workshops where you basically solve little exercises that each take a couple minutes to do. And the first one's on HTML, the second one's on JavaScript, and then the third one's on Node.js. And so I expect for most of you, the first 2 will be relatively easy, and so it shouldn't take more than maybe an hour or so if you've recently taken like CS 142, the web class. But if you're a little rusty, that's okay. Just work your way through the workshop exercises, and then it shouldn't be too bad if you can make it through that. And I expect that the Node.js stuff will be new to probably most people in here. Who's used Node.js like extensively before this? Kind of? Okay, yeah. So you might have used it, but like there's a bunch of sort of stuff that I don't think most people have touched. So the exercise will go through all that. And this is kind of what it looks like. It's really cool. So it's a little terminal. Like you run a little program in your terminal, and it pops up like these little activities, and you select one, and then you kind of you basically have to write a file that matches what the test is expecting, and then it sort of evaluates it for you. It's really fun. I enjoyed going through these when I was learning. Cool. Any questions about any of that? Okay. Cool. So a little bit of background about the course. So this was originally a class called CS 241, Secure Web Programming, that was offered back in 2011. So I was an undergrad, I was class of 2012, and I took this class in I guess it was my, 2011? That would have been my, I want to say it was my sophomore year, spring quarter. And it was taught by Dan Bonet and John Mitchell. And it was really great. It was my favorite class. It was so awesome. It was my first security class, and I was super hyped about all the material. The guest speakers were amazing, and it really gave a sense for like the fact that this stuff is approachable. And you can, especially because it's the web, it's relatively easy to just sort of get your hands dirty and try things out, like start sending requests to a site and see what happens, like play around with various APIs and see what you can do. And so I hope that that's something that you can all take away from this class, the feeling that you can actually go out and maybe look for vulnerabilities and see what you can find. Yeah, so anyway, when I came back to Stanford to finish my master's, I was like, why is this class not offered anymore? And I went and talked to Dan and John, and they were like, well, Dan said, we're doing blockchain now this quarter, so I'm like, web security is more important than blockchain. I mean, blockchain's cool, I take that class too, but I mean, come on, if you don't have security, then you don't have anything. So anyway, web security is, everyone thinks their own class and their own subject is the most important, but web security is actually the most important. Anyway, so that's what this class is. This is sort of bringing the class back. Why is the number different? Some other random class took 241 in the intervening years, so we got a new number. But it's originally that class. So I wanted to start by just sharing a few stories of stuff that, like, after I took this class, what I was able to do, and I think that will just emphasize the idea that security is this fun thing where anyone can do it, and once you have the security mindset, which is really what the main goal of this course is to have you all leaving with this idea of what is the security mindset when you're writing code and when you're looking at stuff. So we're going to just go through a couple of things just some stories about a couple of cool little things that I was able to do after I took this class. And while I was in the class, I was learning web development, and one of the APIs I encountered was this thing called local storage. How many people have heard of local storage? Okay, it's what it sounds like. It's not a crazy API. It lets you store like a string basically in the user's browser, and it can be up to 5 megabytes. But because I was concurrently enrolled in this web security class, while I encountered this, I noticed that the API supposedly had a limit of 5 megabytes, but you could work around it and basically fill up the user's browser. And yeah, I mean, if you sit on this tab here, your whole computer will just run out of space, and then your OS will crash or whatever. You'll run out of RAM because it'll start swapping. So this is a thing that I just literally, as a sophomore, ran into it. And I'm like, oh well, okay. I have this security mindset. Like, this doesn't seem like it's a good idea. Mm-hmm.
What's the workaround? How do you do that?
Oh, how do you do it? Yeah, great question. So every site can store 5 megabytes, but sites are defined by, in this case, like a subdomain is considered a completely separate site. And subdomains are completely free to generate. Like, anybody can, if you buy a domain for $10 a year, you can generate an infinite number of subdomains, like 1 dot, 2 dot, whatever, and each of those is given 5 megabytes. So you just sit there and you create these little iframes, and you just tell them, hey, store 5 megabytes, or store 5 megabytes, and you fill up the user's hard drive with cats. I mean, so just clearly there was an oversight in the design of the API. This is fixed now in all the major browsers, but at the time when I found it, everybody except Firefox was vulnerable to this. Yeah, so I mean, just like a little thing like that. But the web is this evolving thing, and there's mistakes that people make, and you could potentially find something like this. Another one that was really fun was, this is a clickjacking attack. So what the user's doing here is they think they're playing a game where they're just clicking on this little button that's moving around. But what's actually going on is there's an invisible window that's positioned directly underneath the user's mouse. And as they move around, eventually they click, and that's me as a sophomore in Frosoco. So pardon how I look, but yeah, this is how I was in the class. Anyway, and yeah, so you get the idea. The user's camera was turned on, and they didn't see any kind of prompt for that, or any kind of nothing to do with any permission. It was hidden there in an invisible window. So you're going to learn about clickjacking attacks. You're going to learn how to defend against clickjacking attacks in this class. So any questions about any of this? So yeah, so the attacker mindset, that's goal number 1 of the class. This is a mindset that will serve you well in your career. I firmly believe that if you're not thinking about, you're not thinking like an attacker while you're writing code, that code probably has problems. It probably has vulnerabilities. And if you're not thinking about like security when you're designing a system, like architecting the way that the whole system is going to work, then the system's probably insecure at architectural level as well. So you need to be constantly asking yourself, like when you're writing code or when you're designing stuff, how could somebody break this? And so we're going to talk about that in this class. Now, hand in hand with the attacker mindset is the defender mindset. I would hope that most of us would want to defend systems more than break them, but maybe that's not true. But this goes hand in hand, and you can't really. The goal is if you're trying to defend something, you can't defend it if you don't know how to attack it. So we have to talk about attacks. We have to know what attackers are doing, what attackers are thinking, what techniques are the attackers using. So yeah, does anyone know, is it harder to attack or harder to defend? Defend, yeah, why?
Because it's easier to spot a vulnerability when you're focusing on attacking, but defend your own code. It's just harder because you basically wrote the code.
Yeah, and do you know, is it possible to like look at your code and figure out if it's secure?
It's hard because you have a lot of bias already.
Yeah, and the attacker knows, like as soon as they find something, I found something, there it is, and then a defender, you can look at your code all day long and there could still be something hidden in there. There could be a bug in something that you're relying on, or something that you're just not seeing right now. So it's much easier to be an attacker. Welcome to the real world. It's not possible to know that your code is secure, unfortunately, but we have to somehow live in that world. And so we're going to talk about techniques for how to live in the real world, basically. But I want to mention really quickly this extra credit policy that I'm really excited about. So anyone who finds a security vulnerability in something during the quarter will get extra credit. And I'm just 1 to 50 points. It could be, it will be depending on what kind of thing you find. But the reason why I'm doing this is just because I think I think it'll be really fun, and I want to see what people come up with. But please don't do anything that will get me in trouble or get you in trouble.
So it doesn't have to be anything like any website in this class, or
yeah, it can be literally anything. So if you get your friend to set up a really insecure website and then you go and find a bug in it, like I'm not going to count that, but. Yeah, and I'm reserving the 50 points. The highest end is like some incredible. It has to be I don't know. It has to be extremely mind-blowing, like something that is going to be in the news or something. So it's going to range a lot, depending on what you find. But so if you're unsure about what responsible disclosure is, I recommend that you go to the Stanford Bug Bounty Program website and just take a look at what Stanford's requirements are for if you find a bug in a Stanford website, what kind of process they want you to go through to report that, and just you can see basic ground rules are don't try to attack something in a way that's gonna destroy it, or don't try to delete data, and if you're unsure about anything, come talk to me. But you can take a look at that just for a rough idea. And again, this is completely optional. Don't feel like you have to do this. It's totally possible to get an A+ in the class without doing this. This is just just throwing it out there in case anyone wants to do it, because I'd love to see whatever you come up with. And I think it'll make the class more fun if you just have that in the back of your mind, like whenever you're looking at something, is there a problem in this? And so this could be any Stanford website, or even when we're looking at web APIs, if you find a way that a web API could be used in a surprising way that wasn't intended to be used, that would count as well. So any questions about this? Okay, cool. Great. Cool. So today we're just going to do a general overview of web security, and then we're going to start in depth on the technical material next time. So let's talk a little bit about why we're here. Why is this class? Why do we talk about web security? What's the reason? Why and in general, why is computer security hard? So we have a ton of code that's out there that's buggy. And a lot of these, think about your own programs that you've written. some of the bugs that you have aren't even security related. It's just hard to make a program that does what it's supposed to do, right? I mean, that's just a general thing that's hard. But even if you get the functionality perfect and you think like, oh, this is perfect, it's doing everything correctly. There's no edge cases I haven't thought of. In other words, it always outputs the correct answer, right? You still could have a security issue, right? Your program could be perfect from a functionality point of view, but completely insecure, right? So it's kind of a different way of thinking. So there's just all this code that is buggy in ways that create security issues. Yeah, and then of course there's social engineering. Who knows what social engineering is? Yeah.
It's where you maybe pose to be someone in an organization and get information you're not supposed to.
Yeah. So you can call up somebody and say, hey, I'm such and such, please give me whatever password or whatever thing. And that's actually so surprisingly effective. It's absurd. I was at DEF CON a few years ago, and there was a guy who was in a telephone booth on stage, and he was just calling up companies. This was like a thing that they did there. This guy was calling up companies and pretending he was an employee there, and started getting somebody to read over the phone social security numbers of employees. He was just doing this on stage to show everybody look how easy this is. I don't know whether that was legal or not, but that was what was going on at DEF CON. Anyway, so it's really easy. And then of course there's just a ton of ways to make money from vulnerabilities, from information that's stolen via vulnerabilities. There's just a lot of money to be had, and because of that, you get this incentive for people to come and look for this stuff. Not everyone is going to be doing it for the joy, like you all are. So there's literally people whose whole job is they wake up in the morning and they're like, I got to find vulnerabilities in something, because otherwise I'm not going to eat, and it just that's their job. That's their job. They just look for bugs. So there's a marketplace for these vulnerabilities. Does anyone know? So there's a difference between vulnerability and an exploit. Does anyone know the difference? Anyone? Yeah.
A vulnerability is the actual bug in the program versus an exploit is the thing that takes advantage of that bug.
Exactly. Yeah. So vulnerability is I found this problem. I can get the website to do something weird, but it's not the code that actually makes it do something malicious, takes over the server or runs the attacker's code. It's sort of it's here's a place to maybe take a closer look, but it's not sort of deployable yet. And so if you find vulnerabilities, that's one thing, but then there's a different group of people who takes those and then sort of weaponizes them and then actually sort of starts to take over machines. And then once you have people who have taken over machines, then you have a different group of people who will be I'll buy taken over machines because I know how to make money from those, and then they'll start to do things with those machines, right? So these are all different marketplaces. So does anyone know what would you do with a machine once you've taken it over? What are some things? Yeah.
A botnet.
Botnet.
A botnet.
Yeah. So what would you do with your botnet?
Start a machine with request and then dice.
Okay, so you can take offline a machine of maybe your competitor or something, or maybe if you don't want to turn in your homework, you can just take down the site and then everyone gets an extension or something. Don't do that. But yeah, that's the idea. Anything else? What else could you do? Mm-hmm.
You can encrypt the disk and have them pay ransom.
Right. Yeah. Okay.
Mine crypto.
What was that? Oh, mine crypto. Yeah, that's a very 2019 thing to do. Totally. You had one? Mm-hmm.
Attack other machines?
Attack other machines. Yeah, if you know, if you know of some other vulnerabilities, why not just try looking at scanning the whole internet and seeing if you can attack those as well. Yeah, that's right. Mm-hmm.
You can install a keylogger and just take people's credit cards.
Yeah, exactly. Yep. And again, there's different marketplaces where some people specialize in stealing credit card numbers, and other people specialize in actually maybe making physical cards that have that information on them, and then some other person specializes in actually figuring out how to go to the either if it's an ATM card, going to the ATM machine and actually taking cash out, or going to businesses and using the card. And there's just all these different sort of markets for this stuff. It's crazy. Cool. Any other ones? Yeah.
Sin spam?
Sin spam. Yeah, that's a good one. Yeah, sin spam. Yeah, if you can use someone else's IP address to send the spam, it's more likely to go through. If it's like a legitimate, if you hack a web server of a legitimate company and then you're using that to send emails, then it's going to appear to be more legitimate. Yep. Mm-hmm.
You can like turn on their camera, record them, and then blackmail them. Take them being bad.
Yeah, that's right. Yeah, that's a pretty dark one, but yeah, yeah. Yep, true. So so these are yeah. Some of you mentioned some of these already. The spam, denial of service to attack competitors, or to seek ransom is one that is actually surprisingly common, where somebody will basically send so much traffic to someone's website that the website will go down, and then they'll say like, pay us this much, and we'll bring your site back up. And the person's losing money presumably during the time that their site is down, and so they're going to pay the ransom. But yeah, one we didn't mention was, so if you take over, so these are all, the interesting is there's all different kinds of angles here. So some of these attacks are targeting like a client machine, so someone who's like a user going to a site and on their browser, and the attack would be targeting the computer that they're actually on. Other ones are, you're attacking the web server itself, and they kind of get different things depending on the target. So if you're, and by the way, if I'm saying you, I'm not talking about you guys. Okay, so we're talking about some theoretical attacker that's not you. So if you attack a server, one of the things you can do is basically make everybody who visits that site get malware on their computer. So, obviously, you can't just you have to know some vulnerability that exists in the web browser that they're using. But if you attack some popular site and you have like millions of people coming to it, then some percentage of those people are going to be running like an old version of iOS or an old version of Android that's going to have a vulnerable browser where the vulnerability is known by everybody, right? And so you can infect a lot of machines that way, just by taking over one server. And then there's data theft. Someone mentioned that already. So this is some stats on different kinds of data that's stolen in data theft attacks. You can see here, by the way, these numbers it's not like 12 people lost information. This is in the millions. So it's, and this is just in California. So this is quite a lot of data theft happening right now. So yeah, we're going to talk in this class about how to make sure that your server is not vulnerable to an attack that would lead to like this kind of information being stolen. But yeah, you can see it's like all kinds of stuff: social security number, payment card, health insurance stuff, driver's license. Yep. And then these are the sort of more recent trends, kinds of attacks that are happening nowadays. Yeah, ransomware is interesting because like in the past when people got on your computer, there wasn't such an easy way to just directly monetize. I mean, they couldn't. They had to figure out something to do with that, like CPU time or that bandwidth that was a lot harder than just directly saying pay $600 to get your files back. And this has all been enabled by cryptocurrencies. So yeah, this is a big one. And then of course there's all these political attacks nowadays, like the DNC hack and all kinds of stuff like that. Cool. Any questions about any of this? Cool. So now let's talk about like web security specifically. So when we say web security, it's a kind of nebulous term. It can mean a lot of different things. So I'm going to just break down a few different ways what we mean when we say web security. So one of them is, by the way, this thing, same origin policy, we're going to talk about this. This is probably the most important concept in all of web security. It is the model of web security for the web. So this is a big one we're going to talk about. But so one idea is like, okay, so we need to be able to have a browser where we can isolate sites from each other. So if I'm on Wikipedia and I'm reading some article and I have a tab open to my bank in the same browser, and I don't want Wikipedia to be able to access the information that's in that page, right? And that just seems like common sense to us now, but that is a thing that had to be engineered. I mean, this is a single program and it has data from these different sources, and we're running code from each of these sites. I mean, Wikipedia is running code on your computer. It's running it in this sort of process. So the fact that it can't just get all this stuff from Make America, that is, that was a thing that had to be designed. And so this is sort of one definition of web security. It's from the browser's angle, like the browser is enforcing certain rules about how sites can interact with each other. Another way that you see sites interacting with each other in a browser context is in this sort of mashup way, where we have content from one source. So in this case, this is an ad network that's serving some ad here on Stack Overflow, and we don't want the code that the ad is running to be able to do anything to the content that's outside of it, right? So again, this is similar to the two-tab situation because the code that's running in both of these contexts should not be allowed to interact with the other context. There's another definition. So that was focusing on the browser side. Another way we can look at this is from the server angle. So say you're writing a web server, right? What does web security mean to you as a person writing a web server? Well, you don't want somebody to be able to attack your server and to take it over to make it do something that it's not supposed to do. So you have some set of rules of like things that you want your server to allow clients to do, and you want to make sure that like a client can't come along and just do something that's not on this like list of things you want to allow. The thing that makes that difficult is that you don't control the client. I mean, so you can. By the way, does someone want to say what do I mean when I say client? What am I talking about here? Client and server. Yeah.
Browser?
Yeah. So the client is the code running in the browser. It's like the JavaScript that's in the page, and it can sort of make these requests to the server, right? So you might think like, okay, I'm making this site, like I'm in control of what the client can do, right? I don't want the client to be able to do, if I don't want the client to be able to do something, I'm just not going to make a button there that lets them do that thing, right? The thing is that you're not in control of this client that's running on the user's machine. They can modify it. They can make it do whatever they want. They can, in particular, they can even generate an HTTP request to the server that a normal browser would never even send, right? Like they can write a script that talks to your server, and like you have to basically factor that in when you're making decisions on the server side, right? So this is an example, of just a random curl request. But this is you might say, well, I'm a user, I'm not going to make a button that lets this request get sent to my server, but someone can still send that request to your server, right? So that's one angle to think about. Does that make sense to everybody? Okay. So another angle is client app security. So that's like the code that's running inside of the user's browser. We need to make sure that a user who's using that can't be attacked by code that's let's say embedded in the URL, right? Like say I click a link and I think, oh, I'm going to Google. Great, it's a safe link. I'll click it. But if there's something in that URL that changes the way that the app behaves once it's loaded up in my browser, and makes it do something that I don't want it to do, that would be bad, right? So common thing you'll see there is this thing we'll talk about later called cross-site scripting. It's where you can basically trick a web app to run code that it's not supposed to run. So one example of this that I thought was pretty funny was so this was like a place where the server was pretty secure. So McDonald's had a I guess this is just their website where you could go and I guess learn about McDonald's products or something, but yeah. But anyway, so maybe low importance context there. But anyway, but so there was a way to basically get the McDonald's site to just send your password to the attacker just by like visiting the site, right? So this is obviously not good. The thing is, like, you might think, well, I would never visit a link that an attacker sent me, right? But it's really easy to get somebody to visit a URL. I mean, you just have to say, like, there are cats behind this link, and somebody will click it, right? There's even easier ways than that. There's ways with zero interaction. You can, just iframe a page, and then that makes the browser just load that page up. And you can do that when they're on a separate site. And so there's just like lots of ways to get, or you can do a pop-up. You can pop up the site, right? So getting the user to actually go to a malicious URL is pretty easy. And so we want to make sure that there's no way that some formulation of like a URL can cause the user's browser to like run code that we don't want it to run. Does that make sense? Cool. This was another version of that attack that happened, or similar, same category of attack, cross-site scripting. What happened here was somebody figured out a way to basically post some code into a WordPress database, and then when the page got rendered, this code would be included, and it would execute. And in particular, what they figured out how to do was, if the user that was logged in to the WordPress site was an admin, then this code would create a new admin user. And because that person was an admin, they were allowed to create a new admin user. And that admin user had like a very secure username and password. And so this attacker just went around and sort of, try logging into like every WordPress site they found using these credentials, and they could get into a ton of people's WordPress installations. Yeah, that was a pretty nasty one. That was actually pretty recent too. And then the last thing I think last way we can think about web security is as like sort of from the user's perspective. So protecting user rights. So there's obviously the social engineering stuff we talked about. So is it possible to design a system that even in the presence of social engineering is secure? Like even if I tell you my password over the phone, right? You can't hack me, right? I mean that's two-factor auth is one way to do that. But yeah, that's a good question to always ask: is how can we make this secure even in the presence of social engineering? And then, in the web, there's this huge industry of tracking people and building up data profiles on them. So you might think, well, okay, web security means as a web user, I don't want that to happen to me when I'm browsing around the web. And by the way, you might think like, I would never fall for a social engineering attack, and like I have all my browser settings configured really well, so this doesn't affect me. But technically literate people fall for this kind of stuff all the time. By the way, I never want to see a headline like this with any of you guys. Please. Yeah. So this is some undergrad at a German university, and he did he didn't do anything like actively malicious, but it was a little dubious. He registered a bunch of package names on different open source package registries, basically places where developers post their code, right? And the names were sort of vaguely similar to popular packages. And what he did was all the code did was it would just send a little ping to his server and say like, hey, I just ran, but it wouldn't do anything else. And he just wanted to see like how many people would typo, and install his package by mistake. So this is called typo squatting. It's when you basically register a name that's similar to something that's really, really, really popular. And it turns out if it's really popular, then some number of people are just going to typo it, and you're going to just get installs just by luck, basically. Yeah, question?
I'm actually curious. Was he ever did he ever get punishment for doing this, or compensation?
That's the real question you want to have answered, huh? No, I don't know. I think that it was people wrote articles about how it was dubious and like how it was not like a good thing for him to have done. But I don't think he actually harmed any systems. So I would guess he didn't. I would guess nothing happened to him. I mean, yeah. I don't know though. We should look it up. But the thing that was particularly sketchy about this attack was that he noted that a couple of the domains that pinged back to him were .mil, which are military. So his code was running in production with admin privileges on a couple of U.S. government military servers, which is that's the part where it gets a little sketch. But yeah, and then he reported that the code ran about 45,000 times in total on 17,000 different domains. Domains, I think what's going on here is it's like JavaScript code that was installed and then deployed and running on a server in production or shipped to a user's browser. And so 17,000 different websites ran the code at some point and pinged his server. Yeah?
The code did what it was supposed to as well, in addition to pinging his server, right? When they installed it, they thought that they had the real one, and it worked like the real one, and it pinged.
I would guess that if it didn't do the functionality of the thing that it was supposed to do, then they would catch it right away. Yeah. So my guess is if I were doing this, if one were to do this, what one would do is,
Also install that.
yep, install the actual one and then just like export that as the functionality of your package, and then just also ping, right? Yeah, and then they probably won't notice.
So why would it be the fault of the student? Because as a user, right, you have a responsibility to know what you are installing and where it's from. So why should you receive punishment rather than should be commended, right?
I mean, I like your attitude. No, I think that makes sense. I mean, I definitely think people should be auditing the code that they're running on their computer. I mean, we're going to talk about this in a later lecture, but the current state of like the open source ecosystem is that the default sort of state of things is when you go to install some popular package, like say React. That's the thing everybody uses for building the front end of their website. You go npm install React, and it pulls down code from like 1,000 different people. I'm not joking, right? Like it's not possible. It's not humanly possible to actually audit all of that, and that's part of the problem. Is like you can say, oh, they should audit it. It's their fault, but like at the same time, it's like people want to get their job done and they just want to move on with things, and so it's this weird. It's just hard. It's a hard problem. Like you can't audit every line of code. So much of that code is changing. It's in flux. But yeah, I mean, ideally you would sit down and you'd look at everything and make sure that it's not obviously malicious. But even then, you're not going to be able to catch everything because I mean, there could be an accidental bug where, there's a bug in there that the developer didn't even intend to put in there. Like they're not even being malicious. They just made a mistake, and you're going to try and catch that too when you're auditing it. You know what I mean? So there's just all kinds of things that come up. But one of the things NPM did, the JavaScript package manager did in response to this exact attack is what they now do is if you try to register a package, they'll look at names of they'll permute the name by like a letter and all the different positions and just see if there's something that's really popular that's named that, and then they'll just deny you the ability to register anything vaguely similar to something popular. So that's like one thing you can do. But yeah, there's still ways around that. We'll talk about other stuff that's happened. Yeah, any other comments or questions on this? Web security? Nice. Cool. So we were talking about like protecting the user from trackers. So this is a cool project that I forget who made this, but it's a Chrome extension you can install that just sort of sits there and watches what domains your browser connects to. And the cool part is it highlights the ones that you've directly visited yourself, and then the ones that you've domains that information has been sent to, just by the fact that you visited a particular site. And so you can see this insane web that appears, even though the user just visited like Ars Technica, Huffington Post, Boing Boing, and a few other sites, but then they end up having like all these different domains being contacted, and you can see the connections between them, and these gives a hint, a taste at the sort of tracking that's pervasive online these days. There's ways to protect against this that browsers are deploying now. We're going to talk about those different approaches, but it's kind of a hard problem because the web was designed from the very beginning with certain technical decisions that just people didn't expect that this would be the world we'd live in later. How many of you have taken a networking class? Okay, so there's similar things in networking where the internet was designed in a sort of more naive era when only academics were using it, right? And so there's these consequences that we face because of that. So let's talk a little bit about why is web security hard? We touched on a little bit of a few of the reasons, but it's a really hard problem. Like fundamentally, browsers are like trying to create this world where you can take code from a random person and just blindly run it on your computer and have nothing bad happen. Like that is just an ambitious goal, I think. You're not inspecting the code to make sure that it's not malicious. You're not doing any kind of checks. You're just running it, right? And so that's the problem. That's one reason why it's hard. We're trying to run untrusted code securely. But also we have, like I mentioned before, different sites interacting with each other in the same user context. We also have a lot of low-level features. People want websites to be able to do more, right? And so because of that, there's all these APIs that are getting added to allow access to the camera, access to the microphone, access to low-level features on a system like, for example, you can run code on a GPU, right? a website can literally just say, I want to run code on your graphics card right now, and that we have to do that securely. It's hard. It's a really ambitious goal. There's also this desire for high performance. So we get lower and lower level APIs. And these APIs weren't designed from first principles. So it's not like some smart people sat down today and said, how would we design like a secure web browser? This has evolved over time. And when the web was first created, it was it had completely different goals. It was for showing people textual documents. It's a completely different goal now. Now we're trying to make it a web an application platform basically, right? We want to be able to run apps on it. And so the fact that just the fact that we were able to evolve the purpose of the web so much is kind of crazy. It's absurd that it even works, frankly. And the other thing that the web has to do that makes the problem really hard, that none of the other sort of platforms that are out there, iOS, Android, Mac, Windows, have to deal with, is the web has very strict backwards compatibility requirements. It's not possible to make changes that break old websites. It's just not a thing that any browser wants to do, and it's just not a thing that no one will go there. If you suggest like, oh, we could make everything better if we just deleted this really annoying feature, you will not have any luck convincing the browser vendors to do that. They just don't want to go there, because say that you're Firefox and you decide, we agree with you, we're going to delete that feature. Now a bunch of websites break, right? What are the users who are going to those sites going to do when they're going there with Firefox? They're going to say, well, Firefox is broken. It works in Chrome, and then they're going to lose users. So that's one reason. But the other reason is just that it's not possible to go and fix all these old sites. There's just so many sites from the past that are like archival in a sense. They're like human history that we can't just break them. And so this is one of the coolest things about the web is you can go and view sites that were created in the 90s and they still work, right? But this makes it really hard to have good security. It's difficult. So yeah, this is the model of don't break the web. You'll hear this in any discussion. If you try and propose anything, people will say, don't break the web. So anyway, this leads to a world where we have just a lot of, a tangle of technologies. That's the way to put it. I love this quote. Modern web applications are built on a tangle of technologies that have been developed over time and then haphazardly pieced together. Every piece of the web application stack, from HTTP requests to browser-side scripts, comes with important yet subtle security consequences. To keep users safe is essential for developers to confidently navigate this landscape. We have a completely different model for what we want the web to do than we did when it was created. Another example of that is HTTPS. So we used to think that we needed to use secure connection to the server only for transmitting information like credit card numbers. But that is completely different now. What changed? Does anyone know? Yeah?
The fire sheet in 2008. There was a browser plugin, and then on the local network, it would get all the cookies that were sent in clear text on the local network, and you could literally get a list of all the Facebook accounts of your friends in the same room. You could push it, and it could get you to their.
That was very powerful. Yeah. So that's the idea that everybody who's near you, who's on the same network as you, who's sitting at the same coffee shop as you, can see your traffic if it's not encrypted, right? So you don't want them to be able to see what's transiting across the wire there. There's another really big thing that happened that made us change our idea of whether to use HTTP or HTTPS. Mm-hmm.
I don't know if this is related, because I know the Snowden incident didn't really have to do with the web, but did that help change the perception of web security?
I think that was a really big deal. Yeah. Ever since the Snowden revelations, we learned that there are governments that are just slurping up everything that they can that's going across the internet, and so if you can look at, I'll show this probably in another lecture, but you can look at the adoption of HTTPS over time, and right around then you just start to see this dramatic rise of sites adopting HTTPS, and you see the browsers pushing sites to do this more and more. You've probably noticed now, your browser will actually just tell you a site is not secure if it's not HTTPS, and you probably see that all the time now. Sort of trying to harass website owners into adding HTTPS. That was a really big one. Also, there's just all kinds of sketch stuff that happens if you don't encrypt your traffic completely. We'll talk about more of those. So I already kind of mentioned this. Yeah, the browser has an impossible task, it seems. It has to allow literally known malicious actors to download code onto your computer, spawn processes, open sockets to any server that it wants to open them to, connect to even potentially other users' browsers, display media in any format, run code on your GPU, and then save and read data from your file system. And it has to do this securely. So it's very ambitious. And talked a little bit about this already, but there's this idea of this division between what people want the web to be. So there's some people who think that it should just be a simple document viewer, and they want sort of like less JavaScript and less features in the browser. And then there's this competing pressure to sort of make the browser basically into an operating system and to put everything into it and to let a site do pretty much anything it wants, but still safely do that. And obviously, the more you go in this direction toward making it an app platform, the harder it is to defend against certain things. And we're going to talk about a bunch of things like that. But just as one example, the more features you have, the more different interactions there are going to be between these APIs, and the more potential bugs are going to be. As you have this combinatorial explosion of different ways you can use these APIs together, basically. So yeah, but it's okay. Everything's okay. The web is actually pretty robust, despite like all these negative things I've been telling you about. It is probably the most attacked platform out there, and it might not have like a clean design, but it's evolved all these security measures over time that collectively make the web pretty robust. And this is a good quote I like that talks about this. This guy, Ilya Grigorik, is really badass. He is a engineer at Google, and it goes, it's all too easy to criticize, lament, and create paranoid scenarios about the unsound security foundations of the web. But the truth is, all of that criticism is true, and yet the web has proven to be an incredibly robust platform. So yeah, it's possible to build really secure stuff. It's just maybe not the way that your site will end up if you don't think about security while you're building it, and that's what this class is for. So we're going to learn to architect secure systems, patterns, concepts, and we're going to talk about all that stuff. And we're going to talk about how to make it so that even if one of these things fails, your site is still safe. So we need to have multiple like backups, basically, so that you can let something can go wrong here. There was an unknown bug you didn't know about, but you're still okay, right? That's very important. Cool. So yeah, just a overview of the different things we're going to hit. So the first part of the course is going to be all about the browser's security model and the same origin policy, which, as I mentioned, is the most important security concept for web security. And then we're going to go into ways to attack the client, so that's the user's browser, and then ways to attack the server. And then we're going to talk about how to do secure authentication, really important concept. And actually, after that, we're going to have the guy from GitHub Security come in and talk about how GitHub is doing authentication with biometrics and stuff like that to increase account security even further. And then after the TLS stuff, so this is HTTPS, so how we do secure secure connections. And after that, there's going to be a guest lecture from Emily and Chris from Google Chrome security team about how they're making TLS really secure in Chrome. And then lastly, we're going to have a bunch of stuff on how to write secure code. Cool. How are we doing on time? 30 more minutes. Okay, so we have time for this. So yeah, any questions about any of this so far? Anything about the course or anything we've talked about? Yeah?
Is there a final exam? Or?
Yeah, there's going to be a final exam that's worth 25% of the total grade, and there's no midterm. Yeah. I think it's like determined based on when the class is at. I don't know off the top of my head, but you can look it up. Mm-hmm.
Does the class count as an elective, CS elective?
Yeah, it does count as a CS elective. Yeah, you can include it on your, as far as I know, you can include it on your program sheet for that. Yeah. And I think any CS course numbered over 100 is allowed to be a CS elective. Yeah. Cool. So if there's no other questions, I'll just get a little bit into the stuff I was going to do next time on just like a review of web technologies. So yeah, I'll talk about just a quick review of HTML. How many people here know this? I don't want to bore anybody, but know HTML? Okay, everybody. Yeah. Okay. Cool. Yeah, pretty much everybody. So yeah, just a really quick review of that. So we want to be able to make documents that look, formatted in some way, and we might start with the text, plain text like this. But we obviously, if we try to give this to the browser, it's not going to know what is a heading, what is a bulleted list, blah blah blah. So we introduce these tags. We surround text with a particular tag to say this text means this. So in this case, we have a heading, we have paragraph, and then who knows what UL is? Anyone know? Yeah.
Unordered list.
Unordered list. Yeah. What's the ordered list? OL. Yeah, okay. Good. And then LI, what is that? List item. Okay, cool. So we're all on the same page. So yeah, this is basically going to make a list. You run that in the browser, you get the beautiful, amazing document that apparently about penguin diets that we have here. And then we have, the sort of context that you put these tags into. This is just the sort of stuff you have to put into every page that gives information about the metadata of the document. Cool. This shouldn't surprise anybody. So now we're going to do a quick review of URLs. So URLs have a bunch of different parts. The most important parts, I guess they're all important, honestly. So yeah, we have the scheme, which is the sort of protocol we're using. The host name is basically the domain name of the server that we're connecting to. We have a port number. Now, path used to be literally like a path to a file on the server's file system that the user wanted to request. Now, oftentimes these days, the server is completely dynamic, and this path can be anything. This is basically just the name of the request that you're making, basically, and the server can just do whatever it wants. But oftentimes it still does point to a real file with that name. That's possible too. And then the query part, this is pretty much only used when you have a dynamic server endpoint, because you want to, these are just parameters that can sort of configure the type of request that's being made. And the way that this works is you always start it with a question mark, and then everything that comes after this is just, it's key equals value, and then ands separate additional keys. So again, key equals value, and if you had any more, it would just be ands all the way through, ands all the way between all the different key value pairs. Yeah, does anyone know what you do if you have an ampersand that you need to put in the key name or the value name? Escape it. Yeah, right. Exactly. So there's a type of escaping that we'll talk about that helps us sort of disambiguate in those situations. But that is one of the core problems of web security. It's this distinguishing between what is part of like sort of the command that you're issuing and what is user input. And you'll see that all the time in a lot of the attacks we talk about. But there's just a little hint at that. And then the fragment. This is a little bit rarer. Who knows what this is?
So it can be used to like anchor you to a point in the document that's returned.
Yeah. So if you have some point in the document that's labeled with this name here, then this will jump them to that part of the page. Exactly. Yeah. Yep. There's actually a new spec that's being considered right now that's really cool. It lets you. So what's the problem with these? The problem is the author of the page has to have thought in advance about potential points in the page that you might want to send people to. So if you're on a page and you want to link somebody to a part of it, and there's not one of these anchors in the HTML, then you can't link them to that part of the page, right? You have to tell them like, oh, scroll down 2/3 of the way, right? There's actually a cool new spec where you can include, I'm forgetting what the character is, but you include some character after the hash symbol, and then you include a string, and then it sort of basically control Fs for that string in the page and just scrolls them down to it. That's not as robust, but it's kind of a cool new thing. But yeah, cool. Any questions about URLs? Sorry, I know it's kind of basic, but I want to make sure everyone's on the same page. Cool. So then in HTML, there's different ways to actually specify URLs. So we have the basic way is you just include the full URL inside. This is a link here. We're just going to include the full URL. But then there's a relative URL, which is going to be based on the page that we're currently on. So say I have this URL and I'm currently, so say I clicked on this link right here, right? So I'm on this URL now. I'm on the 2019, news/2019. And then I see this link here, right? If I click this, where am I going to go? Anybody know? Sorry, I want to call on you, but I want someone new too. Mm-hmm.
Is it that URL/September?
That's correct. Yeah, it's basically just whatever sort of page you're currently on. It will append that to the end. Now, I don't want to get too much into the weeds here, but yeah, that's basically right. It's like you're currently in this folder, and then you want to go to this, so you sort of just tack that on. That's right. Yeah. If there had been something after this slash here, then you know what would happen in that situation? So say we were on 2019/October, and I clicked on the September link. What would happen then? Huh?
That'd be a 4 not found.
Why?
Because there is no /October/September.
So the interesting thing there is that, it's a good thought, but the trailing slash actually matters in that situation. It's really annoying. But basically, if you were on /October and then you go to September, it's going to say, oh, well, like you're sort of in this folder, the 2019 folder, and we'll just take the October. It'll take the October part off and replace it with September. But if you added a trailing slash, now you're fully in that folder, and it won't do that. If it doesn't make sense, don't worry too much about it. But yeah. So this is the URL that it's sort of the same as. And then there's one other way to do it, which is called an absolute URL. This one, you sort of start the link with a slash, and does anyone know what that does? Mm-hmm.
Well, it gets you to the domain name /events, so it removes the whole path and then replaces it with hingga.
Yeah, it's very similar to what would happen if you were in your terminal and you did that. It's going to take you up all the way to the root. I have a pointer somewhere here I can use to point. It's easier. Oh, wow. Okay. Is it? Nope, it's not working. Oh, there it is. Cool. That's cool. Nice. That's awesome. Yeah, so basically, what was that? Oh, yeah, it's really weird. It uses a gyroscope, so it somehow, it like knows as I move. It's not actually pointing to anything. It's just really weird. Anyway. Here we go. Yeah, so we have the slash here, so what we're going to do is we go to the root of the site here, and we add /events on. So we'll go to stanford.edu/events. Cool, and then there's one last way that you can do it is a fragment URL. So this is just going to tack on the fragment, the part of the page you want to scroll to, basically onto the current URL that you're on, and it'll scroll to an element on the page that is labeled in this way right here. Cool. And so there's a bunch of HTML tags, image, video, audio, canvas. In particular, the ones we're going to spend a lot of time talking about in this class are link, style, and script, because these are where sort of all the attacks are. They all involve these tags. And we're going to talk a lot about just some of the decisions that were made when these tags were introduced and how we're still living with the consequences today, and how we sort of have to contort ourselves around those decisions in order to make our stuff secure today. It's very interesting, but that's, again, like one of the consequences of the fact that the web is just, we can't break backwards compatibility with old websites. But yeah, so with link and style, we're just quickly how those work. Those are for CSS, so you can include an external CSS file with the link tag. And for inline CSS, we use the style tag, and we just put our CSS directly into the page, just like that. Any questions? Cool. And then for JavaScript, for that one, I don't know why it's not consistent with CSS, but we don't use link for that. We use script. And then we can reference external stuff with source, and then inline we just sort of paste the JavaScript in there, just like that. I guess one of the nice things with it being like this is you can find out if there's JavaScript by, like, if there's a scripts tag, you know it must be JavaScript. But anyway, yeah. Cool. Cool. So now just a couple of words. That's everything on HTML. Now I'm going to talk a little bit about JavaScript, and then I think we'll be good. So a lot of you might have a lot of opinions about JavaScript already. Who here would say they have a negative opinion of JavaScript? Raise your hand. It's okay. I won't be mad. Oh my God. Is that why you all took this class? Because you wanted more reasons to hate JavaScript? Well, I have to admit, I'm a fan of JavaScript. I actually think it's great. So bear with me for a second. One of the things that makes it great is I think it's very fun because it's very immediate. Like you can get a lot. I guess this is true of any scripting language, but you can just sort of start to play with stuff in a way that's really nice. And one of its, strengths and weaknesses is its flexibility. In the early days, JavaScript was an absolutely terrible language, and the flexibility that it had actually let people work around the terribleness because you could extend a bunch of the built-ins and you could sort of make up for the deficiencies of the language. It was really nice. But nowadays, as JavaScript has improved and starts to actually have a lot of the features we want, the flexibility leads to potential for too much flexibility isn't good because it removes assumption. It gives you sort of more things you have to worry about. You have to assume. For example, I'll give you an example. There's a thing in JavaScript called undefined. Who's heard of undefined? Okay, hopefully most people. It's like null or something like that. But in JavaScript you can actually say undefined equals true. I'm serious. And then anywhere someone's checking to see if something's undefined, it'll now be a truthy value. Like that shouldn't be allowed. That's a little too much flexibility, but that's the kind of flexibility where the trade-off was made. Let's make things flexible because you probably know the story about Brendan Eich and how the language was made in 10 days. And I don't know if people know that, but basically the language was made in 10 days. You can kind of tell. But because of that, one of the best decisions that was made was, we don't know. We're probably making tons of mistakes when we're making the language because we only have 10 days. So let's throw in some flexibility so we can make up for the mistakes later. That was the one bit of wisdom that was put in the early days that really made it have the longevity that it's had, in my opinion. And then of course it's pre-installed on every device in the world. Everybody has a browser, and especially on desktop, everybody has the dev environment built in because you can just right-click inspect any page, and bam, you have dev tools, you have a console, and that's kind of cool. Cool. So now let's talk about Node.js. So Node.js is basically JavaScript on the command line, and why does it have to be a different thing? Why is it called Node.js? Why is it not just JavaScript? The reason is that JavaScript was intended to be a language that runs in the browser, but at some point some people came along and realized, well, if we could just use this as an arbitrary scripting language to let us write any kind of scripts we want, similar to how we would do with Python, that'd be pretty cool. And unfortunately, because it was a web language, it didn't have a bunch of faculties that a scripting language should have, like being able to read files or write files, right, or make socket connections and stuff like that. And so Node.js had to come along and add functionality that a good scripting language would need. So it added things like file system, HTTP, DNS, sockets, and stuff like that. And also added a module system so we could require code from other places because that wasn't part of JavaScript. And also support for binary data because before that existed, you literally had to do everything with strings. And it's not really very easy for you're trying to work with video data or some kind of other data. You don't want to be dealing with everything as a string. But as JavaScript has improved, we actually need less and less of these things that Node added in. Because JavaScript has become a better language. So that's what Node is. Any questions about that? Apologies if this is too much review, but I promise we're going to get to the really exciting stuff soon, next class. Okay. So one thing I want to dispel really quickly is I think part of the reason JavaScript has such a bad rap is because people lump all of the different ways they've experienced JavaScript and into one bucket and then blame it on JavaScript. And like I said, I agree with most of the criticism. It is kind of a bad language in a lot of ways, but I don't want it to be blamed for things that are not its fault. So one thing to do is to disambiguate where the different APIs that we're using come from. So there's a language spec for JavaScript, which is a bunch of features that are included in the language itself. But then when JavaScript gets embedded in a browser, the browser provides a bunch of additional APIs, right? So how many people know what the document object model is, or the DOM? Right, okay. So all those APIs are not part of JavaScript. Those are provided by the browser. The reason why is if we're using JavaScript on the command line, we don't need a DOM. There's no page to manipulate, right? So that all comes from the browser. And honestly, that's where most of the bad APIs are. They're from the DOM. And then there's a bunch of stuff that's provided by Node if you're using Node.js. So like something like array, right, is built into JavaScript itself. Something like document.createElement, that's a DOM API, so that'll be coming from the browser. And then if you're in Node.js, you have this nice read file API, which lets you just read a file off of the user's hard drive, which obviously that doesn't belong in the browser, right? So just something to keep in mind when you're seeing JavaScript APIs, to know where they're coming from. They're not, these are not really JavaScript, right? Yeah. Cool. So the last thing I want to talk about is that the browser has a lot of crusty old APIs because it's such an amalgamation of old crap, and in a lot of ways. But some of it hasn't been removed. And one of the things I just want to show you guys to excite you a little bit is I whipped something up before class. Does anyone know what these APIs do? They're kind of obvious based on the names, but somebody want to say, like, what does window.open do? Yeah?
It opens a brand new window with the desired URL.
Yeah, right. Yeah, so it's basically a pop-up. That's the pop-up API. You can blame pop-ups on that. And then move to and resize to, I guess, are also kind of self-explanatory. They let you move a window around and resize a window. You might think in 2019, a browser should not be able to do this anymore. But you'd be wrong. A browser can. And I'm going to show you a demo that I made before class that I think is pretty hilarious. Let's see. How do I turn this? Okay. Cool. So this is the kind of fun you can have with the browser, because it's okay. So should I do it? Come on, I should, right? Yeah. Life is too short to not click the link or not do the thing, right? So okay, let's do it. So hold down the space bar. Oh wait, no, it's not working. What's going on? Hold on. Let me start over. I think it might be because I don't have multiple screen support. Okay, hold on. I'll just switch to mirroring. Oh no. I promise it's not supposed to do that. It's cooler than that. Here we go. Mirror. Okay. Now we'll do restart it. Okay. Cool. Okay. So I'll hold on the space key. Okay. So it's setting up the game, and then now The cool part is, notice my mouse is not even holding the window by its title bar. It's literally just following my mouse around. It's moving itself to stay centered on the mouse. Yeah. So yeah, that's the web. What was that?
Can we access this too?
Yeah, I'll post the code if you want to look at it. Yeah, it's honestly, if you want to like use the code and make variations on this to make your own games and stuff, that would be super cool. Anyway, but yeah, this is cool. I guess I have a bug where it sticks to the top. It's a 106A bug right there. There we go. I win. Okay, cool. Anyway, yeah, thanks. Cool. So yeah, that's something you can do. But yeah, the web is full of this kind of stuff. Honestly, that's why it's fun. That's one of the reasons why it's fun, in my opinion. But yeah, anyway, I think that's basically it. Come back next Thursday for more on. We're gonna do cookies, sessions, HTTP, and if we have time, we'll get to the same origin policy. Cool. Thanks.